Hello, dear students. Welcome back to Functional Studies 101. Today, we are going to be looking at the mock exam that was given to the students in the University of Lepzeig in Germany. So, I will answer the questions on this tutorial randomly, beginning with problem number 2. But before that, if you are new to this YouTube channel, kindly hit the subscribe button and don't forget to turn on the notification bell so that whenever new uploads are made available, you will not be left out. There are more videos to come. And also, when you watch this video, make sure you like and share it to your friends, your classmates, and others. Let the video go viral. So, while you enjoy the video, let's get started. Before we get started, like I said, we are beginning with problem number 2. Okay, before we get started, I would like you to follow alongside with a piece of paper and a pen, or a book preferably, so that when whatever I'm doing here, you'll be able to write it down and also follow along. So the very first question we have on problem number 2 was given for 5 points sequence. You have to evaluate the limits of this. They compute this limit as n tends to infinity of the cube root of n plus 1 minus the cube root of n. So what we have to do in this problem is to know how to simplify this, because if you just plug in infinity, as n gets large, this number also gets larger, minus, and then now this other n here gets larger, so you'll be having infinity minus infinity, which is what? An indeterminate form, because you don't even know how large this number is compared to this one, as n is large. Remember, infinity is a symbol showing that a number is relatively large. If it is negative, it means it is negatively large. Now, we have to simplify this, so we have to recall this identity, that the difference of 2 cubes is equals to a minus b. The 2 cubes, a and b, a cube minus b cube, is same as a minus b multiplied by a squared plus ab plus b squared. This is standard identity. So in that case, we will call this our a and this our b, right? So that we'll have to use this identity, to use it, this a minus b here, so that we'll divide, right? We'll divide both sides of this, both sides by a squared plus ab plus b squared. So doing that, we'll have a minus b to be equal to this divided by this, as you can see. From here now on, we are going to let a to be this first part of the expression, while minus b will now become the second part, as you can see here, so that we'll be able to utilize this identity that we have deduced from this one. So replacing, I'll be having this 1 cube, that's a cube, you replace the cube root of 1 plus this other cube minus, okay, minus the cube root of n other cube, divide by a is what? Cube root of 1 plus n, it is squared, plus the product of a and b, so this times this, as you can see there, plus now b squared. B is a cube root of n, so you have cube root of n and it is squared. From here on, I will now copy this expression in the next slide so that we'll simplify it together. This is method 1, okay? Follow along. So let me just copy the previous expression that we had so that we simplify it together. We had this expression. From this expression, we have to know that when you have a cube root and you raise that to the power 3, it will just cancel out the power. The cube root means this quantity n plus 1 is raised to the power 1 over 3. And then now if you raise that to the power 3, the 3's will just cancel out, leaving out n plus 1. Same thing will happen here. You will be left with n. So at the end of the day, we have at the numerator n plus 1 minus n divided by the denominator. Okay. Now, don't bother about simplifying the denominator because all the terms are positive. All the terms are positive. Okay. All the terms are positive. N minus n is 0. You are left with 1 at the numerator, and that will be equal to that. Okay. Don't bother about the denominator because all the terms are positive. From this stage, we will now have this as our final result from the previous slide. Computing the limit as n tends to infinity of the cube root of n plus 1 minus the cube root of n, that result will be equal to what? The limits as n tends to infinity of all of this. You just copy and paste, okay? Because we are proving that this is simplifying to this. From here now on, as n tends to infinity, this denominator gets very large, so it tends to negative to positive infinity. At the end of the day, our limit will be 1 over infinity, which is what? 0. So this is the value of this limit, 5 points. If you do just this, you have your 5 marks. Okay, and I'll show you another method. Viewers, we have come to the end of problem 2, and don't forget to turn on the notification bell. Like I told you, this notification bell, subscribe, very important. Subscribe, turn on that bell so that whenever I'll be uploading this type of content, you'll be the first to be notified. Thank you for watching, and see you on in the next problem. Stay tuned and stay blessed. This is Temgum 48 signing off. Bye bye.